As AI moves from experimentation into production, organizations run into a new set of problems: inconsistent behavior, unpredictable performance, and costs that are hard to control. Those problems only get solved when AI is operated like enterprise infrastructure, not a side project. That becomes especially clear in healthcare, where AI doesn't just answer questions, it interacts with live patient data. Here, we're using an embedded care assistant inside the EHR. It's powerful, but without guardrails, it's also where things can go wrong. First, let's look at a normal, expected use case, summarizing patient data the clinician is already viewing. Now watch what happens when someone tries to override the assistant's instructions. Without guardrails, the assistant loses its sense of scope and starts behaving as if it has unrestricted access. This isn't an attack, it's a well-known prompt tactic, and it's exactly how data exposure happens in real deployments. Now, let's enforce those boundaries. We're not changing the application, and we're not retraining the model. We're applying security guardrails in transit. Same user, same patient record, same prompt. This time, the assistant refuses and explains why. This is enterprise AI security. Define the role, enforce the boundary, and make behavior predictable before AI ever reaches clinicians. Once AI behavior is governed and safe, the next challenge shows up immediately: scale. This isn't a single clinician, it's hundreds of users sharing the same AI service. At that point, performance stops being about requests and starts being about how fast tokens are delivered. On the right, you can see the LLM backends and the signals used for routing. Right now, routing is based on traditional server response time. The request goes to the fastest responding backend. The response comes back and everything looks fine. This is what most AI integrations look like today. Now, backend conditions change. Response time still looks acceptable, but token latency has increased. Same prompt. Because we're still routing by response time, traffic keeps going to the backend that looks healthiest, but unfortunately, it delivers tokens slowly. This is where traditional load balancing breaks down for AI. But what if we route traffic based on LLM token latency? Same user, same request. This time, it's routed to the backend that can deliver tokens faster. Nothing about the request change, only the routing signal. AI-aware load balancing keeps performance predictable at scale because it optimizes what users actually feel. But performance alone isn't enough. When AI becomes shared infrastructure, you also need enforceable controls, so one user or workload doesn't consume everything. And here's the first control problem. When AI is shared, one user, or an internal automation, can consume a disproportionate number of tokens. This is no longer normal human interaction. It's high-volume, repetitive usage that would eventually degrade the experience for everyone else. Fair use policies enforce token consumption per identity over time. And when a user or process exceeds their allocation, that identity is throttled. Everyone else continues without delay. This is precise enforcement. Contain the offender, not the platform. Now this is a user limit, but we also have limits on the LLM model. Even paid AI services enforce caps, daily budgets, per-minute limits, or model-specific quotas. In production, you don't want those limits to turn into user-visible outages. That's why we run a more powerful primary model and a less expensive fallback model. When the primary hits its cap, you automatically spill traffic to the fallback LLM. No failure, no manual intervention, the service stays online. That's continuity. Limits are enforced, but users keep working. This is what it looks like to operate AI effectively. Security defines what the AI is allowed to do. Performance ensures it behaves predictably at scale, and control makes sure usage stays fair, costs stay governed, and limits never turn into outages. All without changing applications or models. That's when AI stops becoming an experiment and starts operating as a reliable, enforceable enterprise service.